And this one, let's take a look at finding some partial derivatives. I'm going to do the partial, say, of x squared y with respect to x. So notice this is x, and then this is x also. Look at the red parts. Now that green y that you see, even though it looks like a letter, you really should see it as a constant. Why does that matter? That matters because it happens that the following then applies. You put the y outside this way. And then you do the other differentiation part of the x squared with respect to x. Again, notice how this is red. Notice how, for example, this whole thing is red. So since this is x here, and this contains x, this part cannot be placed outside, but the y doesn't contain x, so it can be placed outside. Keep that in mind. So go to the next step in the process, and then you just apply the power rule, luckily. So you have y, and then you're going to have 2x raised to the 2 minus 1. So this part, the red part there, as you can see, that is the power rule. So I bring the 2 down, and then I do 2 minus 1 in the exponent. Okay, then continue down below, I clean up. So y and then 2x raised to the first. Again, this red one nobody writes normally, so we just write y 2x. You can write this as 2yx, or you can just as well write it as 2xy. So these two lines at the very end, these two bits, it doesn't matter how you write it. Y is some number, and x is some number. It doesn't matter whether you do 2 times 3 or 3 times 2. See, it's the same thing in the end. Okay, let's move on. Another example here, different variable differentiation. So derivative, say, of y cubed times x squared or something like that with respect to, let's say, y this time. So what matters is this has y and this has y, and this is only x squared. So the x squared is constant with respect to the y, so it goes outside like that. And then what's left under the differentiation operator would be the y cubed part like this, because this has y and this has y. So the x squared goes out. And then from here, we're going to use the power rule. So I'm not going to color code the x squared. I'm going to have x squared and then 3y to the 3 minus 1. So this is the power rule in the red part there that you did in calculus 1. And I'm going to have x squared and then 3y to the second. Now we are, for example, free to write this as 3x squared y squared, or just as well, you can say 3y squared x squared. It makes no difference. Again, because when you plug in a particular x and y, both x squared and y squared are just numbers like 5 and 10, depending on the inputs. So it doesn't make any difference how you multiply them. So you can say, right here, let me color code these, y squared x squared, or you can put the x squared first, followed by the y squared. Not important. Same thing with the 3. You can place it anywhere, but by convention, constants like this 3 here are usually placed out front. This is an example here, so I'm going to do the partial, say, of x squared y plus 2xy with respect to y. So what's important is that there's a y here, and there's a y here, and this contains y. You know, make that y cubed, though, so it's more interesting like that. So we will be differentiating the red parts and then copying the x squared and the 2x out. Let's go through that process a little bit here. So this here is a single term, 2xy, and then x squared y cubed is a second term. There are two terms in our expression, so you need the 2 times to have the following, in other words. X squared y cubed separated with the y in the bottom. So again, this matches. This will be applied to this, and the x squared parts you're going to copy out. The only difference is this is going to say 2xy with respect to y. Again, this is red, and then 2x, that's going to get copied out and placed out front. Then you continue down below. So you're going to have, again, we're differentiating with respect to y, so x squared goes out. And then what's left over is, let's see, y cubed over y. So this matches one more time. You see this, that matches, plus, and then the 2x goes out. And what's left over is just y, and then y in the bottom. Again, this matches, and then this matches. So you copy your x squared. Then you differentiate by the power rule, so 3y squared minus 1 plus 2x. Now, what do you put over here? You can always imagine when we say y, what we really mean is y to the first. Let me delete that like this for this part, y to the first. So by the power rule, what this is going to give us is, let's see here, let me move in. 1 down y raised to the 1 minus 1. That's then going to give us x squared and then by to the first, to be careful, plus 2x, and then y to the 0. So x squared, just by, that's everybody writes it normally, plus 2x, and then y to the 0 right here, the red part, that's equal to 1. If we multiply that by that 1, this whole expression I've just highlighted becomes 1. So you end up with 2x times 1, you see? Then you continue. So you can write 3yx squared, for example, plus 2x. But this is just a form of the answer, so let's be clear, a form. And you can just as well write be x squared y plus 2x, and this is an equally valid form of the answer. So let me zoom back out so you can see all the work. It's quite a lot here. If you have to, pause the video, right? This will be the top that we did the first 2 examples. So pause the video, flip them over. Anyway, I hope this is helpful. Please be sure to subscribe, like, and share. I'll see you in another video.